to anion analysis, but we will be focusing on chloride and nitrate group anion. Okay, so sulfate anion also consists of many types of anion, right? Last week, 3 weeks ago, I think, 3 weeks ago, we learned about that, and then we move further today to the topic of chloride and nitrate group anion. Okay, now chloride group consists of thiocyanate, chloride, bromide, iodide, and sulfide. Yeah. So these 5 are sulfide. Yes, this is the English term is sulfide. Sulfide. Okay. This is thiocyanate. Okay, thiocyanate. Okay. Now, nitrate groups is nitrate, nitrate, chlorate, and then oxalate, C2H3O2 negative. Yeah. Okay. So in this topic, there are 2 groups, yeah, chloride groups and nitrate groups. Chloride group consists of 5 anion, yeah, whereas nitrate group consists of 4 anion. Okay, now so let's start with thiocyanates. Yeah, thiocyanates. Let me check to make sure everything is correct. Yeah, I don't want to give you guys the wrong terminology. Yeah, I have to be careful with all the terminology. Okay, let me make sure. Okay, thiocyanate. Okay, now, so first the solubility. Yeah, so if we mix thiocyanate with silver and copper, yeah, it will be insoluble in water. But if we mix it with mercury and lead, yeah, it will be a little bit soluble. Sparingly soluble means it is sort of soluble, but not a total soluble. So sparingly, a little bit soluble. Yeah. Okay. Now next, yeah. So the solubility here, you can see the list. This is the data. The data should be at 20 °C, and you can see here silver thiocyanate. The solubility is 0.0003 gram per liter. Now, for copper, it is 0.0005 gram per liter. So basically, these two, this top two, is insoluble in water. Yeah, because it's four numbers behind the dot. Yeah. Whereas mercury and lead, yeah, mercury thiocyanate and lead thiocyanate, here you can see the solubility is much higher compared to silver and copper. For mercury, it has solubility of 0.7 gram per liter, while lead thiocyanate has a solubility of 0.45 gram per liter. Yeah. And only these four have a low solubility. Yeah. But other metal are soluble in water. Yeah. Finish writing this? Okay. Next, let's continue. So basically, to test thiocyanate, we will be using sulfuric acid. Yeah, the first reagent that we will be used to test thiocyanate is sulfuric acid. Now, if we mix concentrated acid with thiocyanate, then there will be a yellow color produced. Yeah. And this is performed in the low temperature. Yeah, cold. Now, if we warm up the solution, then the yellow color will be changing into a violent reaction. Yeah. Why the violent reaction occur? Because it will produce carbonyl sulfide, and the carbonyl sulfide will have blue flame. Yeah, blue flame. Yeah, so there is a step. So you mix sulfuric acid with thiocyanate. The solution will be changing into a yellow color. This is at cold temperature, and then when you warm it up, then the reaction will be violent. Yeah. Why it is violent? Because carbonyl sulfide is forming due to the warm up the reaction. Yeah, due to the warming up the reaction. Okay, now this is the reaction that we are talking about. Yeah, you mix thiocyanate with sulfuric acid in the presence of water, right? And then you heat it up, you warm it up, and the carbonyl sulfate is forming. And the carbonyl sulfate is in the form of gas. That's why the reaction is violent, because maybe it will be bubbling up. And then you can see here ammonium NH4 plus, and then sulfate anion is forming due to this reaction. Okay. It's good for you guys to write down the reaction and try to understand what is happening for this testing of thiocyanate anion. Okay, and then this is another gentle reminder. Don't wait until last minute for you guys to study, because Whatever we learn in class will be in the test. Yeah, similarly with the midterm, right? But if you don't study, of course, you won't be able to work on the problem. But if you study little by little, right? Read the textbook. I told you my source of lecture is Fogel, right? Find it in the internet if you don't have it, and then you will be able to work on the test. Yeah, if you study starting now. Okay, don't wait until last minute. Okay, now, so the reaction that we see from previous slide, this reaction, this is a complex reaction. Yeah, why it's complex? Because we have sulfur dioxide. Yeah, sulfur dioxide. Now, the sulfur dioxide here, if we mix it with solution, it will make it lose color, decolorize, so lose color. Yeah. Okay. Now, in the reaction for using sulfuric acid, carbon dioxide also can be formed. Yeah, can be formed. Depend on the concentration of sulfuric acid. Yeah. Now, if it's the concentration is a little bit higher, the carbon dioxide will be formed, and then you can detect it, the carbon dioxide. Okay. Now, formic acid also can be detected from the reaction. Yeah, so either carbon dioxide and formic acid, you can use it to detect thiocyanate by reacting thiocyanate with sulfuric acid. But how you can detect it? By using different concentration of sulfuric acid. Yeah. Now, okay. Now, so if we use 3 molar, yeah, 3 molar acid, there will be no reaction. Yeah, it's not 3 molar. This is, I need to fix it. It's 2.5 molar. Yeah, 2.5 molar. No reaction with a cold temperature. Yeah, but when you boil it, then the yellow solution will be forming. Different from it's quite different from the concentrated sulfuric acid, right? If you mix it concentrated sulfuric acid with thiocyanate, it will immediately form a yellow color solution in the cold. Yeah. And when you heat it, it will form a gas. Yeah, a gas, a carbon sulfur gas. Now, but if we use a low concentration of sulfuric acid, there is no reaction occur in the cold temperature. But when you heat it, then the yellow solution is formed. Why does yellow? So what is the yellow solution? Yellow solution is a mix of sulfur dioxide and carbonyl sulfide. Yeah. Okay. Now, so this is why I said using different concentration of sulfuric acid will give you guys different phenomena. Yeah. If you use like maybe 1 molar of sulfuric acid, then this reaction will be slower. Okay. Okay. What is this? Okay. Now, so the first reagent is sulfuric acid. The second reagent is silver nitrate solution. Now, silver nitrate solution, yeah, if you mix it with thiocyanate, will have a physical appearance of white color. And then there will be a precipitate of silver thiocyanate. So this is silver thiocyanate. So mix with silver nitrate solution, you mix it with you mix it with thiocyanate, then you will get silver thiocyanate. Yeah, this silver thiocyanate, the color is white and in the form of precipitate. So it won't be soluble. Now, how to make this silver thiocyanate soluble? You need to mix it with ammonia solution. But then again, if you mix it with low concentration of nitric acid or dilute nitric acid, the silver thiocyanate will be insoluble. Yeah. So this is the way you analyze thiocyanate using silver nitrate solution. Okay, finish, yeah? Okay, so now let's see the reaction. The reaction is thiocyanate anion. You mix with silver nitrate solution. You will get a silver thiocyanate, and you can see there is a down arrow indicating that this is a precipitate. Then if you mix the precipitate, yeah, the silver thiocyanate precipitate with ammonia solution, you will have the soluble of silver ammonia. And I always remind you guys, whenever we have ion in the reaction, it means these two are soluble. But if you have down arrow, it is precipitate. Yeah. Okay. Now, so you can see here, this is soluble, right? Soluble. Now, so let's see if we remember at the beginning we said that if we have a dilute sodium chloride solution, it won't be able to dissolve silver thiocyanate, right? But if we mix silver thiocyanate with sodium chloride and then we heat it until boiling, then we will have a silver chloride precipitate. Yeah. Okay, now let's see how the reaction of silver thiocyanate with sodium chloride. Now you can see here, this is silver thiocyanate that are in precipitate form. We added with chloride, sodium chloride, and then you can see here the thiocyanate replaced with a chloride ion. That's why we can see a silver chloride precipitate, and then we have a thiocyanate ion in the solution, right? So you can use this method to separate between thiocyanate and then silver halide. Yeah. Okay. Now, so you remember, right, from this reaction, we have this thiocyanate ion. Now, this thiocyanate ion, you can detect it by mixing this solution, right, with iron trichloride. Now, when you mix iron trichloride with this, yeah, thiocyanate, then you will see a color, yeah, a color can be detected, yeah. Now, this is one way to detect the thiocyanate, and the other way, the silver thiocyanate, you can burn it, yeah, you can decompose it. Why? How you decompose it? You ignite using a sodium carbonate, yeah. You ignite using a sodium carbonate. So this is the way we analyze thiocyanate ion. So first we use sulfuric acid, yeah, different concentration of sulfuric acid will give us different analysis. The second one, we can use silver chloride, sodium chloride, yeah, sodium chloride, and then we can see that a different color will be changing, different precipitation, and that's how we detect thiocyanate ion. Okay. Okay. So next, we will try to understand chloride. Yeah. So the first anion that we are studying is thiocyanate. The second one is chloride. One second, I need to find. Okay, chlorides. Now, chlorides here, most of it are soluble in water. Yeah. So you can see here mercury chloride, yeah, silver chloride, but lead chloride here is a little bit soluble in coal, but once you heat it, it will be soluble in the boiling water. So for lead chloride, the solubility will be depend on the temperature. In the cold, it will be insoluble or a little bit soluble. But once you warm it up until a boiling point, then it will be soluble in water. Okay. Now this is the soluble, yeah, chloride that are soluble in water, but these four are insoluble in water. That is copper chloride, bismuth oxychloride, antimony oxychloride, and then mercury oxychloride. So these four are insoluble in water. So you can, the first thing that you will be working on if you want to test chloride anion is you mix it with metal, yeah, then you will be know based on the solubility, yeah. If you mix it with copper, bismuth, antimony, and mercury, the chloride will be insoluble. But when you mix it with silver, mercury, lead, most of it are soluble, except for the lead. The lead you need to warm it up until boiling point, then it will be soluble. So that's the first method of identifying chloride. Yeah. Now, the reagent that you can use to identify chloride, the first one is concentrated sulfuric acid. So when you mix, yeah, concentrated sulfuric acid with chloride, then there will be a decomposition. Yeah. Now, in the room temperature, it will happening a slight decomposition, but once you warm it up, yeah, then the decomposition of a chloride will be complete, and the hydrogen chloride will be released, yeah. The hydrogen chloride will be released in the form of gas, yeah, hydrogen chloride gas. Okay, no. So this is the reaction. So chloride, you mix it with sulfuric acid, and then you warm it up. Then the hydrogen chloride gas will be formed, will be evolved, and the sulfate hydrogen there will be in the solution, since this is in the ion form. Now, what do you think the characteristic of hydrogen chloride gas? What are the characteristic of hydrogen chloride gas? Anyone can tell me? Okay, finish this. So if you cannot answer it, let's continue. Okay. So the hydrogen chloride gas is a pungent. Pungent. What is the meaning by pungent? It's like it makes you suffocating. Yeah. Maybe the the feel is similar with Bakelin. Did you guys ever use Bakelin?
Yes, ma'am.
Bakelin, the one that we use to use bleach to bleach our clothes, right? So I don't know why. I don't know if you guys have ever do this experiment. So I do this one time, right? I like to clean my closet, my WC, yeah, using Bakelin. Yeah, sometimes like you wash your WC, yeah, with brush, it won't be able to make it clean, right? Now this is a tips for you guys. So I put Bakelin into the WC, yeah, and then I wait for a while. And then if I go into the bathroom, suddenly like I feel like I'm suffocating. Why? Because the Bakelin produce some gas that are make you suffocate. So that's how is it, how the physical property of hydrogen chloride gas. So it makes you suffocating, yeah. But then the bathroom will be clean totally without you use much energy to brush it. So that's how strong is it, the Bakelin, yeah. So this is also happening with the hydrogen chloride. So the odor is pungent, and then you can see a white fume, yeah, a white fume. And if you mix it with ammonium, then there will be a ammonium chloride. Yeah, ammonium chloride with a white cloud. Yeah. So if you mix it in the test tube, right? Then in the wall of the test tube, it will be like a white cloud. Yeah. And then if you put it in the litmus paper, it will be turned blue. Yeah, from red to blue. Okay. Hold a second. Yeah, someone called me, so I need to. Yeah, sorry. Okay. Did you guys finish writing this down? Yeah. Okay. Now, next, if we have a manganese dioxide, yeah, if we have a manganese dioxide, we mix it with concentrated acid, and then we mix it with chloride, then we will have a manganese 2 plus. So we will have a soluble, yeah, soluble solution, yeah. So we mix manganese dioxide, sulfuric acid, and then chloride, right? And then we gently warm it, and then what will be happening is there will be the chloride will be soluble, and then also it will release Cl2 chloride gas, yeah, chloride gas. or we can see chlorine, yeah, Cl2, we call it chlorine. Chlorine gas will be released. Yeah? Okay, the reaction, so the chlorine gas, yeah, this is also suffocating, yeah, suffocating. Like I mentioned, if you do experiment with Bakelin, right, then you will smell something that makes you suffocate. And the color is yellowish green color, yeah, yellowish green color. Okay. Next, so if you use litmus paper, right? In litmus paper, you mix it with chloride, chlorine, and then it will change, yeah, into blue, yeah, blue color, yeah, and then the hydrogen chloride, it will be oxidized to chlorine. Okay. Now next, yeah, this is the reaction. You can see the manganese dioxide. We mix it with sulfuric acid, and then we mix it with chloride. You can see the manganese will be oxidized to manganese, will be reduced to manganese 2 plus, and then there will be this is I make a wrong sign. This should be evolve of gas. Yeah, the gas will be evolving. Yeah, and then sulfate will be forming, and then water. Yeah, so this is the reaction that we just mentioned. And then how you detect chlorine? You detect it by use litmus paper, right? You mix the chlorine with a moistened litmus paper, then the litmus paper will turn into blue color. Yeah, and then also you can smell the chlorine. The smell is pungent. Yeah, it's suffocating gas. Yeah, so it's different if you have hydrogen gas. There is no odor in it. Yeah, there is no odor. You cannot smell anything in the hydrogen gas. But when it produces chloride, then you will know the chlorine is there. Yeah, because the color, the smell is really makes you hard to breathe. Okay, so next we study bromide. Yeah, bromide. So what else we already studied today? What are the anion that we already studied? Thiocyanate, chloride, and then next we will be studying bromide. Yeah. Now, for bromide, first, bromides also there are several metal bromide that are insoluble in water, such as silver bromides, mercury bromides, and then copper bromides. And similarly with chloride, lead bromide is also sparingly soluble in coal. So once you boil it, it will be more soluble. And other bromides are soluble. Okay, now, so the first reagent that we will be using to test bromide is again concentrated sulfuric acid. So if we mix concentrated with sulfuric acid with potassium bromide, yeah, then what happened is we will see a reddish color, reddish brown solution. Yeah, and the reddish brown solution will produce fume, will produce gas. The gas is identified as hydrogen bromide. Yeah, hydrogen bromide. Okay. So next, this is the reaction. So you can see here, when we try to analyze bromide, in this case, we will use potassium bromide. And potassium bromide, we mix it with sulfuric acid, yeah, sulfuric acid. And the hydrogen bromide will be released, right? And this is lower concentration of sulfuric acid. Now, when we use a higher concentration of sulfuric acid, you can see here we have a 2 mole, yeah, 2 mole of sulfuric acid. You can see here it will not evolve hydrogen bromide anymore, but it will evolve bromine gas. Yeah, bromine gas, and then sulfur dioxide gas. Yeah. So different concentration, yeah, then it will be a different gas that will be released. Okay, now, so these two reaction, you perform it in the cold or room temperature. You can make it faster, so the reaction can be faster if you warm the solution. Yeah, warm up the solution. Now, instead, if we use phosphoric acid instead of sulfuric acid, we need to warm it up first. And then when we warm it up, we can see that hydrogen bromide will form. So only using sulfuric acid that you can produce hydrogen bromide and bromine. But if you use phosphoric acid, only hydrogen bromide will be formed. Yeah. So that's the difference between using sulfuric acid and phosphoric acid. And this is the reaction. So potassium bromide, we mix it phosphoric acid, and you can see here hydrogen bromide will be released, and hydrogen bromide property are similar with hydrogen chloride. So much information, right? So much information in less than 1 hour. Okay, so that's why study from now. Yeah, don't wait until last minute. I saw that you guys copy a Fogel textbook last midterm, right? I saw some of you, right? Now why don't you guys also, like, after class maybe, right? You can start reading that. Is it in Indonesia or in English, the Fogel textbook? Is it in Indonesia, in Bahasa, or in English? The one that you guys copy.
In Bahasa, ma'am.
Bahasa, okay. So maybe it will be easier for you to understand, right? Since in Bahasa. But I think for me personally, right? I like to read a textbook in English rather than in Indonesia, because sometimes when you read it in Indonesia, in Bahasa, maybe there will be a loss in translation, right? That's my experience, right? So it's better that you read it in in the English language, right? Maybe it will take you double effort, right, to read it. But then the knowledge that you gain also will be much more ingrained in your brain. Okay. Now, next second reagent that we will be using is manganese dioxide and concentrated sulfuric acid. So we mix the solid in the solid form of bromide, yeah, and then we mix it with manganese dioxide. We mix it again with sulfuric acid, concentrated sulfuric acid, and then we heat it up. Then it will produce bromine gas. The color will be reddish brown. Reddish brown. Okay. Now, the bromine gas you can identify first by smell it. Yeah, the odor will be similar with chlorine. Yeah, it's a pungent smell, irritating odor. The second is by using litmus paper. Yeah, so you bleach litmus paper, then you can see bromine color changing. And the third one is when you use starch paper, yeah, you mix it bromine, then the color of the starch paper will be changing into orange red. Yeah. And then the last one is the last method to identify bromine is by using a filter paper. But the filter paper, you already like bleach it, you already like put a fluorescein in the filter paper. And when you use filter paper to capture the bromine gas, the color of the filter paper will be changing into red color. Yeah, red color. Did you guys already start your lab?
Not yet, ma'am.
Yes. Did your assistant already contact you guys?
Yes, ma'am. Already, ma'am.
Yes. Okay. When will the lab will be started? After Idul Fitri holiday? Or
On Friday, ma'am.
huh?
Friday.
This
Yes.
Friday. Okay, because last Friday is holiday. That's why you guys haven't started yet. Okay, so this Friday, and then let me see. But next Friday we will have a holiday, right? Next week. So you guys do the lab again April 28, right? Okay. Okay, I just want to make sure that your assistant already contact you guys. Okay. Now, so this is the reaction. So potassium bromide, we mix it with manganese dioxide, we mix it with sulfuric acid, and you can see here bromine gas is released. And then this is what we have is Mn4 plus reduced to Mn2 plus, and then we have also a sulfate anion and then water. Okay. Now next, we will be studying iodide. Iodide, yeah. Iodide. Okay. Now, you can see here, similar with chloride and bromine, the first method we can identify iodide is by looking at their solubility. Now, the solubility of iodide here, similar with chloride and bromide, where silver, mercury, yeah, copper, and lead, we can consider as the least soluble salt, yeah, least soluble. Okay. Next here. So the first reagent that we can use is sulfuric acid. Now we mix sulfuric acid with a solid form of iodide, and in this case we don't have hydrogen iodide, but iodine gas will be formed. Then if we warm it up, yeah, warm it up, then there will be also a violet vapor evolve, yeah, the violet vapor. And then when we the violet vapor, violet vapor, right, and then we make it close to a starch paper, the starch paper will be turned blue color. Okay. Now next, yeah, you can see here, if we react iodide with sulfuric acid, depend on the concentration of sulfuric acid, some of the reaction can form a hydrogen iodide. So not only iodine will be evolved, hydrogen iodide can be formed also, but a little bit. And then how we can see, how we can analyze hydrogen iodide is by using the test tube, right? And then we blow with our breath, right? And then there will be a white fume produced. Yeah, now there will be white fume produced. And for this experiment, right, the sulfuric acid here will be changed into sulfur dioxide, hydrogen sulfide, and then sulfur. And then the proportion will depend on the concentration of sulfuric acid. So you can see here the reaction, how the reaction will appear, yeah, like what will be the product that will produce during the reaction will depend on the concentration of the sulfuric acid. Yeah. Okay. Now, so these are the reactions. You can see iodide. We mix it with sulfuric acid, right? Iodine can be formed, right? This is like a concentrated sulfuric acid. Now, if we use like a less concentrated sulfuric acid, mix it with iodide, then hydrogen iodide will be formed. Yeah. Now, more concentrated sulfuric acid used in the reaction. You can see here, this is 2, right? This is 1, and this is 4, right? You can see here, more gas is evolved because for this reaction, only 1 mole gas is forming. But then for this higher concentration of sulfuric acid, you can see 3 mole of iodine gas will be formed. And then adding to that, right, for this case, sulfate ion is forming. But for higher concentration of sulfuric acid, you can see a sulfur precipitate will appear in this reaction. Now, increasing the concentration again, because this is 4, this is 5, you release more gas, and then not only iodine gas that will be released, but also hydrogen sulfide will be released, the hydrogen sulfide gas. Okay, so you can see here different proportion of sulfuric acid that you use to react with the iodide, then different gas, different amount of gas, and also different types of gas will be produced. Yeah. So this is one way you can detect of iodide. Okay. Hey, now finish this, finish writing this. Finish. Okay.
Finish, ma'am.
Now let's see. So we see hydrogen sulfate, right? Different concentration. Now next, we can analyze also iodide using phosphoric acid. So when we mix phosphoric acid with iodide and then we warm it up, then a pure hydrogen iodide will be evolved. Okay, now next, yeah, if we mix manganese dioxide, yeah, without acid, only manganese of no, if we mix manganese dioxide, sulfuric acid, and iodide, only iodine will be formed. Yeah, and then the sulfuric acid will not be reduced. Okay, let's 4 more minutes. Yeah, 4 more minutes. So that I know today is so much information that I bombarded you guys. So maybe you need to take a break, right? So let's stay in the class 4 more minutes. Okay. I know it's different. Like if in the class, it doesn't matter if we stay 1 hour, 40 minutes straight, right? It differs from Zoom. Zoom, like we need to focus on the screen, right? It's more tiring, right? I understand that. Okay. Finish this, writing this. So I guess like when you compare chloride, bromine, and then iodine, you can see the similarity, right? You can see the similarity of method identify these three anion. Okay. Now, this is the reaction. So we mix iodide with manganese dioxide, and then we mix it with sulfuric acid. You can see here, iodine will be formed. Manganese will be reduced to manganese 2+, but the sulfuric acid, it is not reduced. It stay as a sulfate anion. Itu sudah harus lagi kita berikan berapa juta gitu untuk inilah dari kesatria gitu. Itu jadi kan kita bikin proposal ya. Okay. Now, so next, the next reagent to identify iodide is silver nitrate solution. So when you mix silver nitrate solution with iodide, this precipitate will be formed in the solution. So you can see here, right? This is silver iodide. Kita bilang berapa kira-kira kita biar sudah ada terapi kita sudah ada. Kita buat di proposal itu dibuat berapa. So the color is yellow. Yeah, the color is yellow. Okay. Now, if you mix it, the silver iodide, it will be soluble in potassium cyanide and sodium thiosulfate. Yeah, but slightly soluble in the concentrated ammonium solution, and then insoluble in dilute nitric acid. So you mix silver nitrate solution with iodide, right? You will have silver iodide, right? The silver iodide soluble in potassium cyanide and sodium thiosulfate, but then like a little bit soluble in the ammonium solution, and then finally totally not soluble in the dilute nitric acid. Yeah, totally not soluble. Okay. Okay. Now, the last one is I'm gonna show you guys the reaction. So this is the reaction, right? We mix iodide with silver nitrate solution. We have a silver iodate that are precipitate. So I forgot here to add. Okay, that's me. Because this is a precipitate, so we have to put down arrow, right? And then the silver iodate, when you mix it with thiocyanate, it will be soluble. When you mix it with thiosulfate, it's also soluble, right? You can see it in the reaction, because both of this reaction are forming an ion after you mix it. So if it's forming an ion, then you know it's soluble in water. Okay. Until here, do you guys have any question? Do you guys have any question? No? So if you don't have any question, we will be meeting again this Friday, because today's meeting is we replace the last Friday since it's holiday, because I don't want us to lose at least we try to meet like 16 meeting, right? If we keep having a holiday, I'm afraid we cannot finish the class, right? So hopefully also, since like 21 April also we will have a holiday, right? Why don't we also have a class on Tuesday, April 18? Do you guys can you guys still meet similarly next Tuesday during this time, like 9:40? Can you guys do that also? so that we won't miss any class. So we meet April 14, right? April 14. And then we meet again April 18. Can we do that? Because the holiday will be started from 19, right? So 18 we still have class. Can we do that? Yeah? Okay. So Yolanda, please remind me again, like you always do. Sorry, last Saturday, I have an emergency. I need to take my mother-in-law to a doctor, right? So I'm MIA, missing in action at the time. So I'm really sorry. But I guess Tuesday is the most suitable time, right? Because Saturday, actually, it's better for you guys to have fun, right? So it's better for us to do that. So make sure so wrote down in your note that we will have a meeting April 14 and April 18. Okay. Okay. See you next Friday. If there is no more question, have a great week. Bye.